Okay, I'm going to show you some techniques for pace and compass mapping. I'm going to use Bowman Field as an example. So this is Bowman Field over here, and this is Brackett Hall right here. This is where the department is. So it's just out in front of the department. And if we zoom in a bit on Bowman Field, as we get started, we really need to do three things. First of all, we'll establish a base point, and then a north arrow, and then a scale. And what we're going to do is establish those things so that our map fits on the page shown right here. This is just depicting an 8.5 by 11 page. So the first thing that we'll do is identify this base point, and there's a light post right here that I use for the base point. You can't really see it in this photograph, but it's right there, and it's something that I can write down in my notes, and I can get back to that point if I need to. And so with that in mind, I have north, and I put that on the page. Usually it's convenient to have that just pointing up. This will be graph paper, so north will go along one of the axes of the graph paper. And then I need to measure the dimensions of the area that I'm mapping. And this measurement doesn't need to be very precise, but needs to be reasonably so. You could pace this distance if you like, or if you're good at estimating distances by eye, perhaps if you're a golfer, you might have developed those skills, then you could probably do it just by eye. You also want to estimate that width because this is the region that needs to fit on the map. So we come up with estimates for those distances, and then in order to have those distances fit on 8.5 by 11, we select a scale so that these axes here with our base point will fit on the map. Now, this is just to get us in the right ballpark. If we're off and we have to put another page, say over on this side, to extend the map over there, that's no big deal. But we want to start off with the intent that the map will all fit on this page. Okay, so here's my starting map. You can see it's on graph paper, and there's the base point. I'm calling it A1, and I've drawn in the scale. 1 inch is 100 feet, and there's the north arrow. Okay, so I'm ready to get started, and the first thing I'll do is to go from the base point to the first point. So I go and I look out and I select a point out a ways, and I determine the location of that point and I plot it on the map. So I'm going to do this with azimuth and distance. So I measure an azimuth. The bearing is 56 degrees from A1 to the next point, and the distance is 362 feet. So I use these see-through rulers for doing this kind of mapping. I think they're great. They're cheap, and they're very effective. They have a protractor, you can see here, and they also have parallel lines, which helps to construct a variety of different things as in the mapping process. Okay, so to draw in the next point, we need to have a bearing of 56 degrees. So I'm using these vertical lines here, and one of those vertical lines I have go through 56. You see there's 50 and 60, so there's 55. That's 56 degrees. You can use these see-through rulers. They're accurate to a degree, and so they have a vertical line that goes through 56 here, and it goes through that point right there. So you might be able to see that line on the graph paper underneath this, the ruler. So it goes through that point and goes through 56, and then this edge of the ruler goes through the point that I'm mapping. Okay, so that's the construction, and that'll get us the right azimuth. And then we measure the distance using this engineer scale. So it's 362 feet, so that would be 3.62 inches. We measure that distance out, and we'll make a tick. So there's 3, there's 3.5, 3.6, So I would draw a line right here on the page and then have a tick that comes out on the paper. And so if we look over here on this one, we can see that tick. That's got the right azimuth and the right distance. So that's my new point. And after I draw that point in, then I also put in these construction lines and I label it as A2. So if we zoom in on the map now, we can see A2 is here, and I generally will designate points using a cross and a circle. So some type of cross. Remember when I drew this first, it was a line like that, and it went out like so. So I've just simply completed that and circled it. If you draw a cross, then you're locating the point quite precisely at the intersection of those two lines. But then by circling it, you make a fairly large point that's easy to see. Some people will draw points as just a small speck like that. That's precise, but it's hard to see. So this cross with a circle is a good compromise. And well, it's not so much a compromise, it's a good way to do both. You can both locate it precisely and make it easy to see. So I put on this point, and I've also drawn in the construction line that I used to go from A1 to A2, that's this line, and I'm writing on the azimuth and the distance. And that's just so that I can keep track of this information. It's also in my notes, but I put it here because if I start to run into problems, it'll be convenient to have it here to check for reference. Okay, so I've got these 2 points in, and then I'm doing also another thing that I think is important to point out. This line here I have labeled as the tree line. And so what I did was to stand here at point A1, and I look from point A1 to A2, and I see that along this line there's this tree line that goes like this. In roughly the middle between A1 and A2, the tree line comes in, and it's just about at the line between these 2 points. So I can say it's right about there. And then about a quarter of the way between these points, from here to say here, I can go to this point, and I measure out, and it's 1 inch equals 100 feet. And so on this scale, one of these blocks is 20 feet. So I've gone here, and what I did at this point was I just paced out here, and I got that it was a little over 20 feet, so I knew where that point was, and I could then just sketch the line in. I knew it had to curve in here, and then I saw it was out about 20 feet away from this line, or so, maybe a little bit more than 20, and then I saw that it wrapped around. So since I was out there and I could see this tree line, I could just sketch this in. And what happens then is the level of detail of my map starts to increase. I start to have some points that are or some features of interest. Okay, so then I need to put in point number 2. Well, the azimuth point number 2 is 314. So the procedure is the same. I lay the see-through ruler down here, so this goes right through the point. And I use a vertical line, and the vertical line goes through this intersection on the protractor and through 314. So I can't go through 314 per se because this protractor doesn't have anything above 180, but this angle here should be 360 minus 314. So what I'm doing is I'm selecting the angle here 46 degrees. And so 46 degrees west of north, and I set up that angle, and then I go and use my engineer scale. I measure the distance, and I end up with this point right here that I'm labeling as A3. And so I continue mapping in the tree line. It's going around like that. And I did that by, as I was pacing off this line, I said, well, after I finished the pace, I then paced out here. And I didn't even write it down. I just pasted off, got that distance, and then I noticed it was about the same distance away from this line, this tree line. And so I just drew it in as I was there in the field. And I also noticed that just about 10 feet away from this point to the south was the corner of this parking lot. And I measured the azimuth, and so I could draw in the corner of the parking lot right when I drew in A3. So the map is starting to gain additional detail. So as the map grows, the information is also being written down in my notebook. And you can see here, this is the base point. It's a light post. The traverse from A1 to A2 consisted of 108 paces, and that's the azimuth. And then I converted the 108 paces to feet. A2 is a signpost, and the tree line is to the south. Then A2 to A3 is this distance, that azimuth, and here is the distance, or the paces converted to feet. And also note here that I wrote the azimuth in the quadrant notation. Just to be clear, this is what I would have written down for my compass. But then when I plot it, it's going to be plotted because the protractor doesn't go to 314. I need to know that 46 number, and so I just put it in my notebook so that it's clear. And then A3, I write a description of the A3 location. It's a decorative rock. And I also note that the tree line wraps around north of A2 by about 40 feet. Okay, so the information really is now in two places, in my notebook in text form and on the map itself as the map is being developed. Okay, so there'll be a couple strategies for plotting multiple points. The one that we've seen so far is to use an azimuth and distance to go from one point to another. We can repeat that, repeat it again, and then generally what's done is to continue along and do this traverse until we can close the traverse. This is ideal because if the last point of my traverse is the same as the first point, then I have an opportunity to assess the degree of error. Now, as we saw previously, whenever we do this, there's some kind of error in the angle and some kind of error in the distance. And so as we go further along the traverse, those errors accumulate. And so we expect that there will be some difference, some error that results in there being a difference between this point and this point. This is called the traverse closure error. And it's an estimate of how good the overall error is. So we go and describe that closure error. And another approach is to use multiple base stations. This is, well, let me go back. So this kind of traverse, this is commonly what you'll do with a pace and compass. You're going from one point to the next and then sketching in details, and then you go and close the traverse as a way of checking. The measurements are fairly easy to make with a pace and compass, and it's fairly easy to move. Now, with other techniques, you want to go and maximize the kind of the amount of information that you can get from each base station. So what you would do is from the first base station, you would go and shoot in several points, and you would then go and from that one base station shoot in the location of another base station, move, and then shoot in additional points. This multiple base station approach is generally what you would do when you're using a transit and a stadia rod. It takes a bit of time to set up the transit, and so you want to maximize the number of points and the value that you can get from each location. So we set up and we shoot in these different points, and then we move and we set it up again and we shoot in a bunch of points. We would probably go and once we move, we would probably go and backsite and verify that we have the correct location. but that'll be the strategy for using the transit. Now, we always want to be able to check the work. As we start off on the traverse, we put in multiple points, and one possibility is that you plot this point in the wrong location. And so, well, how are you going to check? And the one strategy would be to from this point go and backsight, and you would go and do this. You backsight from the location where you are and draw in this angle, and this is the angle from that you're determining by standing at this point and shooting in this previous point, and then you shoot back to this point and get this angle, and those points intersect here. So this is a way of determining the location of this point, and you could then demonstrate that this point is the correct location and this point is has been plotted in error. So this is a way of picking up errors. One of the things, though, that I should point out is that this is a way that you can actually go through and construct it. I always am looking at my map. I look down at the map, and then I look up at the area where I'm mapping, and I see if the points look like they're in the right place. Because often you can tell just by looking that this point is just doesn't seem to be located properly. And if that's the case, then you go and use one of these backsighting techniques to check and see if indeed you can verify that the location is okay.